This is the screencast for section 1.7, example 4. Finding the model and solving. Alright, so grain is leaking through a hole in a storage bin at a constant rate of 8 cubic inches per minute. So every minute another 8 cubic inches is being added to this cone, and it's getting bigger and bigger and bigger. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to its radius. Okay? If the cone is 1 foot tall now, no, we were using inches before, so I'm going to change that 1 foot into 12 inches tall now. How tall will it be in 1 hour? So I'm looking for how tall. I'm looking for h. Now remember, h equals the radius. The height equals the radius. So wherever I see radius, I'm going to plug in height instead. I know the volume of a cone is 1/3 pi r squared times height. Now I said I want to use height because I'm looking for how tall this cone is, not for how radius it is, how tall it is, the height. So I'm going to take this and change it to volume equals 1/3 pi h squared times height. So that would be volume equals 1/3 pi h cubed. So it says if the cone is 1 foot tall now, how tall will it be in an hour? Well, unfortunately, I don't know how tall or how fast the cone is growing height-wise. I only know how fast the cone is growing volume-wise. So I need to calculate the volume now, calculate what the volume, how much volume I will add, so where it will be in an hour, and then I'll be able to find the height. So I need the volume now is 1/3 pi times 12 cubed, which in my calculator is 576 pi. So that's my volume now. The volume added over an hour, 60 minutes, well, it's 8 cubic inches per minute, so that's 8 times 60, so that's 480 cubic inches. So the volume in an hour is going to be 576 pi plus 480. So now I have the volume, I just need to calculate what the height is. So I'm going to take 576 pi plus 480 as my volume, and I'm going to solve, because that's supposed to equal 1/3 pi h cubed. So first things first, I'm going to multiply both sides by 3 and divide by pi, or in other words, multiply by 3 over pi. I know this is a big mess, but we're going to do this in my calculator later. I don't want to do anything now because there will be a bunch of rounding and my end result is going to get less accurate and less accurate the more I round. Now, to solve for both sides of this, I have to, to solve for h, I have to cube root both sides. Now that's something I can do in my calculator and find out approximately what h is. So I want the cube root, so math number 4 is cube root of parentheses 3 over pi, close those parentheses, new parentheses, 576 pi, oops, that's e, plus 480, close the parentheses. I think that's all I want. I get the height is 12.98 inches high. The now try problem number 37, finding the model and solving again. Water is stored in a conical tank with a faucet at the bottom. Alright, so I've got a cone tank and a little faucet. There's my little faucet. Water. At the bottom. The tank has a depth of 24 inches and a radius of 9 inches. So this out here is 24 inches. And then this here is 9 inches. And it's filled to the brim. If the faucet is opened to allow the water to flow at a rate of 5 cubic inches per second, what will the depth of the water be after 2 minutes? Well, I'm trying to find depth, which to me, which does mean height. I have a relationship between the radius and the height that they alluded to. The radius and the height are proportional of a cone, if you remember that from geometry. So the radius over height, let's see, our radius was 9, our height was 24, so I cross multiply 9h equals 24r. Now since I'm trying to find height, I'm going to solve for radius so that every time I see radius, I can plug in an expression that still has height in it. So that's going to be 3/8 h, that was a mouthful, equals r. The volume of the cone is, let's see, 1/3 pi r squared times height. So the volume now of all the water is going to be 1/3 pi, what did we say the radius was? 9 squared times, and then the height we said was 24. So that's going to be 9 times 9, 81 times 24 divided by 3. That's going to be 648 pi. That's the volume now. Now let's see, in 2 minutes, we're going to be losing some water. How much are we losing? 5 cubic inches per second. Okay, so 5 cubic inches per second means we're going to be losing, let's see, we're going to multiply that by 60 to get cubic inches per minute. So that's 300 cubic inches per minute. And there's 2 minutes, so we're losing 600 cubic inches per minute. So that's going to be, so volume in 2 minutes is going to be 648 pi minus 600. All right. So now I got to take that, that's going to be my new volume, 648 pi minus 600, and that's going to equal 1/3 pi r squared times height, but I don't want r. I want height. I only want height. So I'm going to do 3/8 h squared times h. So now my volume is a function of height. I can just solve for height. Let's see, so 648 pi minus 600 equals 1/3 pi. Let's see, 3/8 squared is going to be times 9/64 h cubed. Now I get to divide both sides by 1/3 pi times 9/64. I'll show you how to do that whole mess in your calculator in a second. What I'm going to do is I'm going to do the numerator first. 648 pi minus 600. That's 1,430, whatever. I'm going to store that above the on key, store as alpha A. So now on my piece of paper, I'm going to put 1435.75 stored as A divided by, now I'm going to find out what the denominator is after I pick up my pen. The denominator is 1/3 times pi times 9/64. Hit enter. I'm going to store that as alpha B. Or actually I just picked D, so D it is. So that would be, what was that? 0.147, we'll just call it 0.15 and we stored that as d, and that equals h cubed. So now I'm going to take the cube root of both sides. So I get h equals the cube root of a divided by d, and that's something I can do much easier on my calculator. So I'm going to do math, cube root number 4, alpha a divided by alpha d, and I get that the new height is 21.36 inches.